Welcome. We are going to see two experiments for Hebb rule. Hebb rule is the basic neural network algorithm. The steps are initialize all the weights to 0 initially, and n is the number of input neurons. The bias is also equal to 0. So this is the network diagram. x1, x2 up to xn are the input neurons. w1 up to wn are the weights, and we have a bias with activation 1. Y is the output function. Wi new equal to Wi old plus xi y. We know all the initial weights are 0. Xi is the input, y is the output. B new equal to B old plus y. This is the algorithm. So now we have a problem. Using Hebb rule, find the weights required to perform the classification of the given input pattern. Plus symbol represents 1 and minus symbol empty space represents minus 1. So we have these two classes. This one is I class and this one is O class. So here the positions are 1, 2, 3, 4, 5, 6, 7, 8, 9. So with this we form this table x1, x2 up to x9. So all plus are 1. So 1, 1, 1 and all empty places are minus 1. Minus 1, 1, minus 1, 1, 1, 1. So this is I class and we have I class target is 1. So output y equal to 1 for I class. Next O class, same way we write all plus as 1 and empty places minus 1. So 1, 2, 3, 4 and fifth position alone is minus 1. All others are 1 and the target class is y equal to minus 1 for O class. So now we'll start Wi. All the weights are initial weights are 0 for I equal to 1 to n since we have x1 to xn. And Wi new equal to Wi old plus xi y as per Hebb rule. So epoch 1 for I class. Wi new W1 new equal to W1 old is 0 plus x1 y1. X1 is this 1, y1 is 1. So 1 into 1, 1. W1 is 1. W2 new is W2 old is 0 plus x2y. X2 is 1 and y is 1. Same way we proceed for this I class. Find all W1 to W9. So this will be the old W1 to W9 when we go for epoch 2 for old O class. So now find the new W1. W1 old is here 1 plus x2 is x1 is 1 into y is minus 1. So 1 into minus 1. So it is 0. Same way find all the new weights for O class. Here for O class the target is minus 1. For I class the target is 1. So we have found all the new weights. So the program x1 is we have written x2 value, x is x1 and x2, y is the target 1 and minus 1, m comma n is the size of the x. W equal to zeros of 1 comma n, initial bias value 0. For I equal to 1 to m, for j equal to 1 to n, W new equal to W old plus x into y, b equal to b old plus y, and display the epochs and weights and bias. So we'll see the program for this in Scilab. So this one x1, x2 value given, x value y, m comma n is size of x, w equal to zeros. Find W new, B new and display the values. So when we run it in Scilab, we have the output here. Epoch number 1, the weights, and then bias value is 1. For epoch 2, which is for O class, the new weights and the bias value we have got. We'll go for the next program using Hebb rule with a target created by AND logic gate. So this is the AND gate truth table 0, 0, 0, 1, 1, 0 and 1, 1. For only 1, 1 the output is 1, otherwise the output is 0. So now in place of 0 write as minus 1 and 1 as 1 itself. So we have this x1 and x2 value. Y value only for 1 it is 1, 1 it is 1, otherwise it is 0. We write it as minus 1. Initial capital B values are 1. Del W1 is x1 W1 equal to W1 old plus del W1. Del W1 is x1y. X1 is minus 1, y is minus 1. So 1 minus 1 into minus 1, 1. This del W1 will be minus 1 into minus 1, 1. 1 into minus 1, minus 1. Del W1 is x1 into y. Okay. And then find del W2 which is x2 into y. Del B is y itself. So same minus 1, minus 1, minus 1 and 1. W1 new is W1 old plus del W1. All initial del W1s are W's are 0. So del W1 will be del W1 new is W1 old is 0 plus del W1 is 1. Now the W1 old is 1, right? So 1 plus 1, 2. 2 minus 1, 1. 1 plus 1, 2. Same way W2 is W2 old 0 plus del W2. So 1. Then this 1 minus 1. So it is 0. Minus 1 minus 0. 0 plus 1, 1. 1 plus 1, 2. And B is del B. B plus del B. Del B initial B is 0. So del B as such minus 1. Here minus 1, minus 1, minus 2, minus 2, minus 1, minus 3. Minus 3 plus 1, so it is minus 2. We have all the new weights and bias values. Now we go for the program. Del W1 is XI, del B is Y. So X1 values are minus 1, minus 1, 1, minus 1. X2 is minus 1, 1, minus 1, 1 it is written. X is X1, X2. M comma N is size of X similar to the previous program. So to have the value for Y target value, if X1 equal to minus 1, you can see here. If X1 equal to minus 1 itself, the target is minus 1 only. So Y equal to minus 1. If X1 equal to 1, check X2. If X2 is minus 1, target is minus 1. If not, target is 1. So with that, we have written this program for I equal to 1 to N. If X1 is minus 1 itself, Y equal to minus 1. Else, check if X1 is 1, then if X2 equal to minus 1, Y equal to minus 1, else Y equal to 1. And B equal to 1s of 1 comma N. For I equal to 1 to N, del W1, del W2 and del B values. Del W1 is X1 into X into Y. Del W2 X2 into Y. Del B is Y. All initial weights are 0. W new equal to W old plus del W1. W2 new equal to W2 old plus del W2. B equal to B1 plus del B. W1, W2 and B1 values and display all the weights. We'll go for the Scilab program. So this is the program which we just explained. So when we run the program, we should get the values for all the new weights and biases. This is about Hebb rule. Thank you.